Notice and wonder, and I would like you guys to just take a look at this image and think about, what do you notice and what do you wonder about that image? And in the chat, if you will go ahead and write what you are thinking, but do not hit enter yet. Don't share those thoughts. We're going to give everyone some time to think, write it out, and then I will let you know when you guys can actually push enter to share. All right, I know some of you might still be thinking and typing out those thoughts. So at this time, we've called this a community return, where we give everybody a chance to think about what's been asked, write it down, and then we ask everyone to hit enter at the same time. So at this time, if you would please hit enter so we can see what you were thinking. I wonder what the area of the shape is. I notice they're all different colors. Lots of triangles. More triangles and other shapes. I notice it looks like tangrams. My favorite color, purple, perfect. I wonder what other shapes I can make with these pieces. Yes, these can be a lot of fun to play with, right? So we are going to be looking at notice and wonder throughout, and various ways we can use this routine. And with this, it's nice to be able to share out the thinking that others have, and it's all valuable thinking because it's just your own noticings and wonderings. So thank you so much for sharing some of the things that you were just noticing and wondering.
The notice and wonder is a short routine that can be used to elicit students' reasoning, to encourage curiosity, to get students to think actively. It's really about students looking at an image, a representation, an equation, a question, and then really just to ask about the noticings and wonderings, what they're observing, and any questions that they might have, and to kind of bring that out, to slow down a little bit and think about the mathematics and how the mathematics works, and to start making conjectures. And so when you give students an opportunity to engage in notice and wonders, it begins to create a safe community for learning. Because again, when kids believe that the teacher or the adults care about their thinking, they'll begin to share. And we'll realize that the students actually learn a lot. And if you were in Doug Fisher's presentation yesterday, one of the things he told us to do was we need to stop teaching kids what they already know. We don't know what they already know if we don't ask them to share their thinking. So, in math, as you know, we have the content standards and we have the standards for mathematical practice. And when students are engaged in a notice and wonder routine, they're going to be engaging very, very specifically in some of these standards for mathematical practice, particularly SMP 1 to persevere in problem solving, to make sense, and SMP 3 to construct viable arguments and critique the reasoning of others. And then depending on the task, they're going to be looking at how they're reasoning abstractly or quantitatively. They're going to be looking and making use of structure, or they're going to be noticing patterns and use some of that repeated reasoning. So it gives an opportunity to engage kids in a lot of mathematics. So here is the protocol. Those underlined words are links that will take you to other resources. But the first thing is to display the problem and read the question aloud, or ask students to volunteer to read the problem. Remind the students to take time to think independently. This is probably where we make the most error for students. We don't give them enough think time. And this is where I remind you that if you have English learners, that it takes English learners more time to process, because they have to read, they have to translate, they have to process it, they have to come up with a response, and then they have to translate it back to English. So it takes them a little bit longer. So we want to make sure that if we want kids to think, we need to give them the time to think. We want to ask the students, is there anything up here that you were wondering about? So first we asked about the notice. We jot down what they notice. Then we ask them about what they wonder, and we jot down what they wonder about. We want to make sure that all the students got a chance to participate. And then we begin to ask questions. And so we want to make sure that we give kids the opportunity to speak more about their own responses or to ask the questions. If you're in an asynchronous model, you would do the same thing. You probably just I would recommend that you make a video of the process so that kids know what to do and what to expect. So sometimes when we do the notice and wonder protocol, we find out that the kids don't participate as well as we had hoped to. And so sometimes there might be some things that we do a little bit differently that will help communicate to the kids that we really do care about their thinking. So we need to communicate that we value their thinking, and so we might stop rephrasing and repeating everything that students say. If something needs to get repeated or rephrased, we want to ask another student to revoice it or rephrase it. We want to make sure that we are not asking questions during the noticing process or during the wondering, that the questions that we ask come from the students, and it happens at the end once everything has been shared. Okay. Avoid praising. So be very neutral about the comments that students are saying, because if you happen to forget to praise one student, that will affect that student's engagement in the notice and wonder routine. But you do want to thank them and acknowledge them for their contributions. So these minor changes in the way that you formulate and you run and facilitate a notice and wonder will begin to communicate to the students that you care about their thinking, because you're not going to take the stage away from them. So then we're trying to change how mathematics is viewed from a gatekeeper to a gateway. And so what Notice and Wonder does is it gives every student an opportunity to participate. It gives them an entry point, which again is important, because if they don't feel like they can contribute anything because everything is way out of their reach, we still want them to contribute, because I can build and I can help them build from wherever they are. Right? It gets everybody engaged, because we set the standard that everybody needs to be able to participate. Everybody needs to provide an idea, something that they noticed, something that they wondered. And then it starts to give us a diverse perspective of how the kids are thinking, and the kids begin to learn about each other and their own, and they begin to decide about people's different strengths, and it begins to spark ways that they can begin to think. Things like, I've never thought of anything like that before. I really like that. I'm going to start to think like that. And then these tasks are open-ended. So if you find that you've got a task that is too close, then remove some information from the task and make it a little bit more open-endedness. That way students can get more involved and more engaged and be able to create some of the mathematics themselves. So the process of sense making begins when we create curious classrooms full of thoughts and ideas. By asking what do you notice and what do you wonder, we give students opportunities to see problems in big picture ways and discover multiple strategies for tackling a problem. Self-confidence, reflective skills, and engagement soar, and the students discover that the goal is not to be over and done, but to realize the many different ways to approach a problem. So it allows students to slow down and think about the mathematics. That's extremely empowering. And that's one way that you can begin to build classroom community that is safe and is focused on learning and not answer getting.